Hey, Logic One. Hope you guys are doing really, really well. Hope you guys had a great weekend too. It was a nice weekend for us as well. Um, so let's go ahead. Let's talk about what we're going to do today. I'm assuming you guys have done your facts practice already. And I want to definitely check up on the facts practice that you're going to do today, the two-step equation. If there's any questions or concerns that you have about solving two-step equations, let's make sure that we talk about it on Thursday, or you drop me an email at colleenteachesmath@gmail.com. Just to let me know how you're doing with it, if it's something you get, don't get, yada, yada, yada. Just because it's super important moving forward. So, yep, do your facts practice. Make sure you do your mental math, all of it, and your problem solving. And then what we're going to do today is estimating square roots and talking about irrational numbers. So estimating square roots is kind of a mental exercise where we have to know all of our perfect squares in order for us to really understand this concept. So you'll see right here, you have 1, 4, 9, 16, 25, etc. These right here are perfect squares, 1 squared all the way through 8 squared. So if I were then to ask you to estimate the square root of 25, you would know immediately that the square root of 25 is 5. If I were to say, what is the square root of 36, you would know we're talking about 6. But what if I were to ask about the square root of 29? Well, I'd have to know that 29 lies between 25 and 36, which are two perfect squares that kind of sandwich 29, or square root of 29. So we would then say that the square root of 29 would have to be between 5 and 6. If you look at it on a number line over here, here we have 5, here we have 6. And if we wanted to do the square root of 29, it'd be somewhere in between here on the number line, right? So we would estimate that it'd be 5 and some number, some amount on our place value, either to the 10th or the 100th between 5 and 6. All right, let's go ahead and skip this page and do a little magic with the computer. Oop, just kidding, I ran out of space, and there we go. All right, here we go, here we go. All right, so just like I said, the square root of 29 is going to be between 5 and 6. All right, so let's look at an example here. It says, between which two consecutive whole numbers is 200, or the square root of 200? Well, on a number line, if you were to think about your perfect squares, you could know that, or you could guess, well, let's start with 10, right? Well, 10 squared is 100, but that seems too small. What if we did 15? We know that 15 squared is 225, and I should probably put my little square guys here, my Radicand symbols. Okay, well, 225 is too large. So we know that 14, well, the square root of 14 is 196. So if we're looking for the square root of 200, that's going to lie somewhere in between here and here, in between 14 and 15. So we would know, let's put it right there, that it would be 14 and some combination of tenths and hundredths. So it'd be 14 and 15 would be the two consecutive integers that the square root of 200 is in between. So now let's go ahead and go to the next problem, or the next idea, which is this irrational number. So at the beginning of our lesson, we talked about the square root of 29 between 5 and 6 is between 5 and 6, the two consecutive whole integers. So if we were to kind of make our estimate a little more detailed, we could try and put a tenth on that whole number to see, just like we said in here, to see what actual number is it the square of. So if we were to bring it, I'm going to bring it down here now. So if we were to try 5.4, so 5.4 squared, when you put that into the calculator, you get 29 and 16 hundredths. So that is too large here because we're looking for just 29. So if this is too large, let's go ahead and try a little smaller. So let's try 5 and 3/10 squared. Well, when we put that into our calculator, 5 and 3/10 squared, we end up getting 28 and 9 hundredths. So that's too small. because we're again looking for exactly 28 or as close as possible. So we could continue and estimate that the square root of 29 is somewhere between 5.3 and 5.4. So it really doesn't matter how many numbers you put in. So if you were to try 5 and 35 hundredths squared, it doesn't matter what numbers you put in here, you're never going to get an exact number for the square root of 29. So it doesn't matter how many numbers we try, we're not going to find a decimal or fraction that equals the square root of 29. So that's why we rely heavily on guesstimating. But if we use a calculator, we could come up with a pretty great looking number that would give us the square root of 29. So if you were to square 29 on your calculator, depending on if you have a TI-83 or TI-84 or even just a standard calculator on your phone, you're going to come up with this number right here. So 5.3851648, right? So we're going to scoot that out of the way. I'll just minimize that. All right, so here we go. So this number is close to the root of 29, but it doesn't equal the 29. So if you were to multiply this answer, so basically square 5.3851648, you would get 14 decimal places. But you would see that immediately the product is not 29.000000 because the digit in the 14th place, that would be over here, is actually 4. Herein lies the beauty of what root 29 actually is. So the root of 29 is a number that cannot be exactly expressed as a decimal fraction. Right here I'm reading, and is therefore not a rational number. So rather, root 29 is an irrational number, and what that means is it's a number that cannot be expressed as a ratio of two integers. So if we think about what a ratio of two integers is generally it has to do with two numbers being evenly divided so that we could get an exact number. Slide this back out. So a number that's irrational cannot be expressed as a ratio of two integers. So we do believe that the root 29 has an exact value, even if it has like a bazillion place values. And we can even look at it in the example of this right triangle right here. So we talked about Pythagorean's theorems last week, and I'll definitely check up with you guys on it on Thursday because it is a huge concept that's very important. So let's go ahead and take a look at this triangle right here. So Pythagorean's theorem would say a squared plus b squared equals c squared. And what that means is the two legs of a right triangle squared is equal to the square of the hypotenuse. So if you look at this with a centimeter ruler, we find that the length is about 5.4 centimeters, which is an approximation of the root 29. So another example of an irrational number include pi. So we've talked about pi before. Another irrational number would be the root of 2, which is the length of the diagonal of a square with sides of 1. So if you have a square with each side of 1, the diagonal that cuts it in half has a measurement of root 2. And the square roots of counting numbers that are not perfect squares, such as any of the roots of the counting numbers that are not perfect squares. So the irrational numbers together with the rational numbers make up a set of real numbers. And this is a huge idea in mathematics, that we have numbers that are rational numbers, we have numbers that are irrational numbers like we're talking about today, and these two numbers combined make up this gigantic numerical system called real numbers. All of the real numbers are represented by points on the number line, are real numbers, and are either rational or irrational. So let me go ahead and do this next example with you. So it says draw a number line and show the approximate location of the points representing the following real numbers. Then describe each number as rational or irrational. All right, so I'm gonna pull this over here so I can use my whiteboard. Dun, dun, dun. All right, so let's go ahead and draw a number line. I'll do it down here. All right, so let's start with what we do know. We do know that pi right here is 3.14. So I'm gonna put 3.14, and that is pi. All right, awesome. So then we also have the root of 2. So that is going to be lower than the smaller than pi. And then we have 2 and 3/10. And you'll notice this line above the 3. Well, that line means that it's a repeating decimal. So we're going to put that in between here. It's less than pi. I'm going to put that over here. And that's 2 and 3/10 repeating. And I think this is -1/2. It's really small on my computer screen, but we're just going to say that it is. So I'm going to put 0 right here. We're going to have -1/2 right there. All right, let's go ahead and turn the page. Oops. Bring this guy over here, and I'll bring my whiteboard over. All right, let's see. All right, so if you look on, it gives you the solution right up here. It was -1/2. All right, good. So here we have the root of 2, which is going to be between 1 and 2. We have 2 and 3/10, which is a repeating decimal, and then we have 3.14, which is pi. So really what we need to now talk about is which ones are rational and which ones are irrational. So again, rational, we have an actual decimal place. This one here is a rational number, and this guy here is a rational number, 2 and 3/10 repeating. Now we have irrational and irrational, because those numbers have a bazillion non-repeating decimal places. We would call these irrational because they're not a ratio of 2 integers. So that is our lesson for today. It's a huge lesson, this idea of real numbers, irrational numbers, rational numbers, and then of course just estimating square roots. I want you guys to go ahead and do the lesson practice, and then any questions you have, please write them down so that either you can email them to me, or we can talk about them on Thursday when we meet up. So yeah, so I hope you're doing well. Looking forward to talking, and if there's anything I can do to help you in the meantime, please don't hesitate to reach out. I'm here to help. Okay, that's it, and we'll definitely connect on Tuesday when you do. Oh, I guess you have a test on Tuesday. Just kidding. Yeah, you have a test on Tuesday. Then we'll connect on Wednesday when we do lesson 101. Okay, bye guys.